All right, this is section 10.1, Outcomes and Events, and we're starting a new chapter here. Chapter 10 is based solely on probability, and so we have a lot of vocab that we need to go over to get us started. Some of these terms you might be familiar with, some of them might be new. I know you guys have worked with probability in the past, but we're going to do a full recap, and then we're going to work our way through this chapter, working with probability the whole time. So, our first vocab word is an experiment. An experiment is an investigation or procedure that has varying results. So varying means that they are different, all right? They're different. So an experiment, for example, could be flipping a coin. When I flip a coin, I have two different results. If I roll a six-sided die, which is just your common die, I have six different results, and so those results are vary. The possible results of an experiment are called outcomes. So the outcomes of flipping a coin, heads and tails. The outcomes of rolling a number cube is 1, 2, 3, 4, 5, and 6 if I roll a six-sided die. A collection of one or more outcomes is called an event. So if I'm flipping a coin and I want to get heads, then the probability of me getting heads is the event. And then the outcomes of a specific event are called favorable outcomes. So, for example, if I want to try to flip an even number, then those would be the even numbers on my number cube, which would be 2, 4, and 6, would be favorable outcomes. So some different vocab words that we're going to work with as we progress here through the chapter. So just an example of what we're talking about here. It says, for example, randomly selecting a marble from a group of marbles is called an experiment. I want to get a marble out of here. That's the experiment. Each marble in the group is an outcome. So I have 6 outcomes. Not all of them are different. There are 6 marbles, but I have 2 green marbles. You can see them here. Okay, so even though it's a repeat, it's still 6 outcomes, but I really just have 5 different colors. Selecting a green marble from the group is called the event. You can see that over here. It says choosing a green marble, and then there are 2 favorable outcomes. So we said there's 6 total outcomes, and then there's 2 favorable outcomes because the event I wanted was a green marble. So there's 2 green marbles. And we can answer this last question here. It says, are the outcomes of the experiment equally likely? And the answer is no, they're not, because you're more likely to get green when you draw these marbles out because there's more green than any other color. They're not all equal. All right, let's look at an example here of a 6-sided number cube. Of course, a cube has 6 sides, so I shouldn't have to say it's a 6-sided number cube. We'll just assume. Part A says, what are the possible outcomes? Well, the outcomes are all the possible things you could get. Remember, we call those the results you could get. So you could roll a 1, a 2, a 3, a 4, a 5, and a 6. You could roll all these different outcomes here. There's 6 of them. It says, what are the favorable outcomes of rolling an even number? Well, there's 3 even numbers, 2, 4, and 6. And then there's 3 not even numbers. We call them odd, but we'll just say that they're not even for now. And that would be 1, 3, and 5. Part C says, what are the favorable outcomes of rolling a number greater than 5? Well, how many numbers are greater than 5? Just one. It's a 6. So there's only one of those favorable outcomes. And then all the numbers that are not greater than 5, 1, 2, 3, 4, and then even 5, because 5 is not greater than itself. It's equal to 5, so we have to list it there as well. And then for part D here, it says, are the outcomes of the experiment above equally likely? Well, you're just as likely to roll a 1 as you are a 6, as a 2, as a 4, and as a 3, and a 5. So they're all equally likely. This is yes. There's not one number that's listed on there twice and makes it not fair. Let's look at another example. It says you randomly choose a letter from a hat, and those letters contain A through K. What are the possible outcomes? Well, we have A, B, C, D, E, F, G, H, I, J, and K. So how many is that? C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just going to keep track of that. There's 11 of them up there. 11 letters from A through K. Part B says, what are the favorable outcomes of choosing a vowel? Well, let's see how many vowels we have here. We have A as a vowel, E and I are all vowels. So there's 3 favorable outcomes, and we're going to list them here as A, E, and I. And then all the ones that are not vowels are called consonants, but we'll list them here as B, C, D, F, G, H, and then J and K. So 3 of the 11 are vowels, and then the other 8 are consonants. They're not vowels. Next example, we have a spinner here. You can see this spinner is definitely not equally likely because there's a lot more red than there is any other color. It says, how many possible outcomes are there? Well, this question isn't asking how many colors are there, because there's only 4. It's asking how many spots can the spinner land on, and there's 6 different spots. So 6 different outcomes. It says, in how many ways can spinning red occur? Well, 3 of those 6, or half of the spots, are red. So we'll put 3 there. And then for part C, it says, in how many ways can spinning not purple occur? Well, if it says not purple, that means any other color except purple, obviously. So we have 1, 2, 3, 4, 5 spots that are not purple. And then it says, what are the favorable outcomes of spinning not purple? Well, there's a red. There's actually 3 reds, so we're going to list that twice. And then there's a blue. And then there's a green. So I've just, can't spell, G-R-E-N. So we have 1, 2, 3, 4, 5 of the spots that are not purple, and then obviously 1 purple spot. Hopefully you're getting the hang of this and you're seeing just how easy these questions are. This is what you'll be doing on tonight's homework, is just listing out what the outcomes are of each of the events and how many there are. This one says, you randomly choose a marble. How many possible outcomes are there? Well, how many marbles are there? There's 1, 2, 3, 4, 5, 6, 7, 8 different marbles. It says, in how many ways can choosing blue occur? Well, there are 2 blue marbles. So 2 out of the 8, or 1/4 of the marbles, are blue. Part C, in how many ways can choosing a not yellow occur? Well, if I ignore the yellow ones, 8 minus 3 yellow ones means there's 5 outcomes that are not yellow. And I did 8 minus 3 because I knew there was 8 total, and I knew there was 3 yellow ones. Sometimes that's easier to find the not yellow ones by subtracting than it is to add them up, depending on what kind of event you're doing. And then part D says, what are the favorable outcomes of choosing not yellow? It wants us to list all 5 of them. So the number we have here for part D should match this number we wrote it up here in part C. And so the 5 of them, I've got 2 blue ones. So we'll list that one twice. A green one. And a purple. So one thing we're going to start working with now is we're going to start making predictions. And when we're working with probability, we can make predictions about what we think is going to happen. In this next example, it says you flip a dime. There are blank possible outcomes. Well, there's heads and tails, so that's 2 possible outcomes. Out of 20 flips, you think you will flip heads blank times. Well, there's 2 ways that we can do this. There's really 3, but I'll just list the 2 right now. So the first way you can do it is by using a proportion. There are, on the dime, there's 1 side that's heads out of 2, right? So the probability of us getting heads is 1/2. 1 out of the 2 options is heads. So if I should get a head 1 out of every 2 times, then how many will I get out of 20 flips? And so we can solve this proportion using cross products. 2 times x is 2x. 1 times 20 is 20. Of course, we know cross products are equal, and then we can solve for x, and we divide by 2 and get 10. Another way that we can do this one is we can use decimals. If the probability of flipping heads is 1/2, that's 0.5. Or 50%, right? So if I want to do 50%, if I know 50% of the flips should be heads, then 50% of the flips, which of means times, and we're going to flip 20 times, means 0.5 times 20, or half of 20, which is 10. So I can use a proportion, or I can use just multiplication. Either way, I guess you're multiplying both ways. Or I guess in this one, you could just use common sense, right? If you know you should get heads half the time, then half of 20 is 10. So we can make a prediction that 10 of these flips will be heads and 10 of them will be tails. Now, will that absolutely happen? Not every time. You could get 9 heads and 10 tails, or vice versa. So we're just expecting, based on the probability, that we'll get heads 10 times and we'll get tails the other 10 times, since it's 50-50. Here's another example of the same kind of problem where we have to make a prediction. It says you spin the spinner. There are blank possible outcomes. Well, there's 5 outcomes on the spinner. Each of them are equally likely because there's no repeating colors. Out of 20 spins, you think you'll spin orange blank times. Well, orange is 1 out of the 5 outcomes. So if 1 out of every 5 spins should be orange, then how many out of 20 spins should be orange? And so we're going to cross multiply 5 times x, 1 times 20, divide by 5, and we should get 4 orange spins. We should. We may not. We might get less or more than that, but we should get 4 orange spins. Or you could use decimals, and you could say, well, if the probability of getting an orange is 1/5, 1/5 is the decimal 0.2, 2/10. And so if I'm going to get orange 20% of the time, then 0.2 times 20 spins means we'll get 4. 0.2 times 20 is 4. So the number of orange tiles we should get is 4. We should spin orange 4 times. This is an interesting one. It's a rock, paper, scissors game. 2 players are playing rock, paper, scissors. How many possible outcomes are there? Well, we're going to fill this chart out to see how many possible outcomes there are. So, if player A chooses rock and player B chooses rock, there's an outcome. Player A can choose paper. Player B can choose rock. Player A chooses scissors. Player B chooses rock. Player A chooses rock. Player B chooses paper. Player A chooses paper. Player B also chooses paper. Player A chooses scissors, and player B chooses paper. If you're not understanding how I'm getting these numbers, I'm choosing the player A option up here first and the player B option second. So then now player A chooses rock, player B chooses scissors, player A chooses paper, player B chooses scissors, and player A chooses scissors, and player B chooses scissors. So we have 9 different outcomes available for rock, paper, scissors. 9 different ways that it could go down when you're playing with 2 people. Of the possible results, in how many ways can player A win? Okay, so obviously rock, paper, scissors. We know rock beats scissors, scissors beats paper, and paper beats rock. So let's see who wins here. In the first one, this would be a tie. They'd have to go again. And then paper covers rock, so player A would win this one. And then scissors would lose to rock. Rock would beat the scissors, so then player B would win this one. If player A chooses rock and player B chooses paper, player B wins. They both choose paper, that's a tie. And if player A chooses scissors and player B chooses paper, then player A will win. If player A chooses rock and player B chooses scissors, player A wins. If player A chooses paper and player B chooses scissors, then player B will win. And if they both choose scissors, there's a tie. So our different options here, I'm going to color them here. Player A can win 1, 2, 3 ways. Player B can win 1, 2, 3 ways. And then they can tie 1, 2, and 3 different ways. So there's 3 ways player A wins, 3 ways player B wins, and then there's 3 ways there's a tie. And these numbers give us the 9, 3 plus 3 plus 3. The 9 different outcomes there. Does one of the players have a better chance of winning than the other player? The answer is no. If you had a better chance of winning, then you wouldn't rock, paper, scissors every time you want to try to beat your friend at something and try to, get the shotgun in your car or something like that, because there's an equal chance that you'll both win and a chance that you might both tie and have to play again. Okay, let's look at some homework type problems. Number 14 is not a homework problem, but it's just like the ones in homework. So I just want to give you some instruction on how to answer these. It says, You randomly choose one marble from the bag. In how many ways can choosing purple occur? Well, there's 2 purple marbles, so you can choose purple in 2 ways. And then it wants us to list those favorable outcomes. Remember, when we worked through the notes earlier, anytime we had a repeating outcome, we had to write it twice. So when it says, what are the favorable outcomes of choosing purple, you would take purple, drag it up here once, and because there's 2 purples, you drag it up here again. And so that's how you'll do that. If it would say not purple, for example, then you'd have to drag the other options up however many times. You can see there's 3 red ones. So you'd have to drag red up there 3 times. If it said not purple, you'd have to drag blue up there twice, and then green and yellow. So you're always going to make sure that this number here matches how many options you have there. So we're going to write purple and purple in here twice so that those numbers match. And then number 26 says you randomly choose one of the cards and set it aside. You then randomly choose a second card. Describe how the number of possible outcomes changes after the first card is chosen. The interesting thing here is that when it says that you draw one of the cards, you set it aside. That means it's no longer there. So with all 5 cards available, the number of outcomes is 5. But then when I go again, and I remove and set it aside, right? When I remove one of the cards, the number of possible outcomes would be 4, which means it's going to drop down. I think it says less outcomes or something like that here because I'm taking away one of the cards. So then there'll be 4. The next time I draw, there'd be 3, and it just keeps getting lower and lower. Now, in probability, we call these dependent events, and we'll talk more about that later in one of our future sections. But if I said, what's the probability that I'm going to choose a blue card? Well, there are 2 out of 5 blue cards. And then if I want to draw a second blue card, knowing that after I just drew one, so I just drew a blue card, then I'm going to set it aside. Now there's only 1 blue card left, but there's 4 total cards left. And so the number of possible outcomes goes down by 1. We call these dependent events. Not something you need to know today, but something we'll definitely work with as we progress through this chapter.